Good morning everyone. Last time we have discussed about the modern periodic table, its shape, blocks and everything. Today we are going to discuss about the positioning of element in the periodic table. So when we discuss about the modern day periodic table, then I have said that the modern day periodic table is based on the atomic number as well as on electronic configuration. So it is the atomic number and the electronic configuration on the basis of which we are going to position the element in the periodic table. So we will see that how we will position the elements in the periodic table, and for that we will have to discuss the position of the element on the basis of their atomic numbers. Here I am taking few of the elements from the different blocks and trying to find their position. So I am taking few of the elements, that is the S block, one of the S block element, one P block element and one D block element. So here I am taking the sodium, atomic number 11. If you have the periodic table at the time, you can see the position of the sodium, where it is, what is the group, period and the block. And I am trying to find, just see and recognize whether it's working or not. So when you will see the sodium atomic number 11, what will be the electronic configuration? The electronic configuration will be 1s2, 2s2, 2p6 and 3s1. Then first one we will try to find the period. The largest principal quantum number in this electronic configuration will determine the period. Then what is the largest principal quantum number? It is the 1, 2, 2, 3. So only 3 is the largest principal quantum number. So what will be the period? The period number 3. Now we are trying to get the block. For getting the block, we will see the where the last electron is lying. In the electronic configuration, you can see the last electron is lying in the 3s subcell, that is the S subcell. And if the electron is lying, the last electron is lying in the S subcell, it will be a S block element. Now the last one and the important one, that is group. What will be the group? When you will see the group, again we will go for the last electron, where the last electron is lying, and first we will see that what is the block. If the block is S, P or D, then in the case of the block S, you will add 0 with the number of electron in the last subcell. In the case of P, you will add 12, and in the case of D, you will add just 2. Why these are the additions? From where these are the numbers comes from? When you will see the periodic table, the S block starts from group number 1. That means before the S block there is no any group, so we are adding 0. But when you will see the P block will start from the group 13. And if it is starting from the group 13, before the P block there are 12 groups. So we are adding 12. And the last one, that is the D. The D block is starting from third group. Before the D block there are 2 groups, so we are adding 2. Here it is the S block, we have to add just 0. And as it is a S block element, we will add 0 with the number of the electron in the last subcell, and that is just 1. Then 1 plus 0 equal to 1. Then this is the first group. You can see the position of the sodium, third period, S block, group number 1, first group. I think it's clear to all of you. Now we are taking another example, that is the sulfur, atomic number 16. For the atomic number 16, first of all we are going to configure, to write its electronic configuration, and for the atomic number 16, it will be 1s2, 2s2, 2p6, 3s2 and 3p4. This is the electronic configuration: 2, 4, 10, 12, 16. Total 16 electrons. Now, first of all, we will try to find the period. And how we have find the period? By finding the largest principal quantum number. In this electronic configuration, it is 1, 2, 2, 3, 3. That is 3 is the largest principal quantum number. No any principal quantum number is larger than the 3. So, this is the largest principal quantum number. That is 3. Then it is the period third. Now, we are trying to find the block. Actually, the subcell in which the last subcell is entering. Here you can see the last subcell, the last electron is moving in the p subcell, and so the block will be p block. And the last one is the group. When you will see the group, then you will find the number of electron in the valence cell, that is the valence last subcell, plus these are the numbers. As the last electron is moving in the p subcell, we will add 12 with the number in that subcell. There are total 4 electrons in the p subcell, and we will add 12 with it, and it will get 12 plus 4 equal to 16th group. You can check it. The sulfur is surviving in the group number 16th, block P, and period number 3rd. Clear? Now we are going to take one more example of the D block elements. How to place the D block elements? This is the block in which we get confused for the placing of these of the element, because the last electron does not move in the valence cell. The last electron moves in the inner cell n-1. Now we are taking the example of iron, atomic number 26. The electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. I think it's clear. The last electron is moving in the 3d, but the valence cell is not the third. Valence cell is 4th. So, first of all, we will try to find the period, the largest principal quantum number, and it is 1, 2, 2, 3, 3, 4, 3. Which is the largest? It's not 3, it's 4. So, the period number 4. This is the 4th period. But where is the last electron? Where it is in 4s? Surely not. It is in 3d. That means the last electron is moving in the d subcell, and as it is moving in the d subcell, it will be a d block element. Okay. Now we are trying to find the group. What is the number of electron in this d? Total 6. And how much you will have to add in the case of the d block? It's just 2. So when we will add 2 with the 6, it will be 8th group. Clear? Then in this way we find the position of any elements. In your homework you will find the position of all the elements from atomic number 3 to atomic number 30. When we discuss about the position of hydrogen and helium, that does not 100% follow these are the conditions. Because when you will see the helium have electronic configuration 1s2, that means it is a s block element, but actually the helium is surviving with the inert gases due to their specific chemical property. And same in the case of the hydrogen have a unique properties, that have a exceptional property. So it is very difficult to position the hydrogen, because hydrogen don't have any octet. Hydrogen have the duplet, and because of the duplet, hydrogen is not capable to show any specific property. Hydrogen is capable to show the property of alkali metal as well as the property of halogen. So it is difficult to position the hydrogen in any of the specific group. You can say the same problem was there in the case of the modern Mendeleev's periodic table, then what is the profit of the modern periodic table? Surely the same problem was there in the Mendeleev's periodic table, but Mendeleev was not capable to explain why the hydrogen is showing such property. But in the modern periodic table, we are capable to explain the reason why hydrogen is capable to show such property. Hydrogen have the duplet having only one electron in that duplet, so it can lose one electron to show the property of alkali metal, or it can gain one electron to complete their octet to show the property of the halogen. And this is the reason why hydrogen is not placed in the periodic table, that is placed outside the periodic table, you can see. Finally, the elements having exceptional electronic configuration, we have seen two elements, that the chromium and copper. How will you place chromium and copper? Because if you will place chromium or copper, you will find that two different elements are positioning on the same position. That means if you are taking the example of copper, the electronic configuration will be 4s1 3d10 after the electronic configuration of argon. And when you will see the zinc, after the electronic configuration of argon, it will be 4s2 3d10. That means both the systems are 3d10. Then how will you position these of the elements? When we are going to position the element in the periodic table, we are not using the exceptional configuration, we will use the general configuration for the element. I am trying to explain by taking the example of the copper, that how we will position the copper. So here it's copper, atomic number 29, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10, that is the exceptional configuration. But when you will take in general, it will be 4s2, 3d9. So on the basis of this configuration, you will position the element, not with the configuration 4s1, 3d10. I have already said it will be the general electronic configuration which will provide the position of the chromium and copper. Only in this case you will use this electronic configuration, otherwise you will use the same, that is the 4s1 3d10. On the basis of this one, what is the maximum largest principal quantum number? Again 1, 2, 2, 3, 3, 4 and 3. The 4 is the largest principal quantum number, and again the period will be 4. When you will see the period, what is the period? You can find, block. You can find that the last electron is moving in the d subshell, and so the block is d block. And what's about the group? There are total 9 electrons in the d subshell, and we will add 2 with it, so it will be 9 plus 2, that is 11th group. So in this way we will place the element in the periodic table. I think it's clear to all of you. In the next video, we will discuss about the periodic trend, the atomic radius, metallic property, non-metallic property, ionization enthalpy, etc. Till then, bye. Have a nice day.